Welcome to The Debate. Today we're digging into the legacy of Albert Einstein. Now, the traditional view holds him up as this architect, a singular genius who deliberately built our modern understanding of the universe with these finished theories. But if you look at the source material, especially from astrophysicists like Jan Levin, there's another story there. So was he really the architect? I'll argue that he was.
And I'll be coming at this from a slightly different angle. I'm not trying to deny his brilliance, of course, but the record shows Einstein was often, terribly wrong about his own work. Levin makes this great analogy that his legacy is really about the crumbs, these incredible ideas like black holes or lasers that he either doubted or just discarded. I'm arguing his biggest contributions were the accidents he left for everyone else, the dogs under the table, so to speak, to pick up.
Okay, I see that. I see the appeal of that argument. But let's look at the bedrock for a second. Between his miracle year in 1905 and general relativity in 1915, Einstein wasn't just stumbling. He was systematically replacing Isaac Newton's entire universe. Newton said gravity was a force. Einstein proved it was geometry. He replaced Newton's neighborhood with a cosmic city, showing that massive objects literally bend space-time. I mean, that wasn't a crumb. That was a complete, deliberate rewriting of reality.
That's a powerful way to put it, I'll give you that. But then what do we do with the Nobel Prize? It wasn't for relativity. It was for the photoelectric effect, his proof that light can act as a particle. Now, this was one of the founding ideas of quantum mechanics, and yet Einstein spent the rest of his life fighting quantum theory, right? He famously insisted God does not play dice. So he basically fathered a revolution and then disowned the child. He was honored for the very thing he refused to fully accept.
That's an interesting point, but I'd frame it differently. He debated the philosophy, sure, but his mathematical framework was, well, it was undeniable. Look at the 1919 solar eclipse. Astronomers saw stars shifting their position around the sun, just as his theory predicted. He proved that light follows the curve of space-time. That established the absolute nature of the speed of light. It changed everything about how we measure distance and time. You just don't do that by accident. That is a master theory making a successful, testable prediction.
But even inside that master theory, he tried to break his own machine. When his equations suggested the universe wasn't static, that it had to be expanding or collapsing, he kind of panicked. So he invented the cosmological constant, which was really just a mathematical fudge factor to force the universe to hold still. He himself called it his greatest blunder.
But isn't it ironic that in 1998 we discovered dark energy, and it's making the universe expand faster and faster, behaving almost exactly like that constant?
I'm sorry, I just don't think he gets the credit for that. He was right while trying to be wrong, and wrong when he thought he was right. He stumbled backward into the correct answer for the energy density of the universe. I mean, that's the poster child for accidental genius right there.
I just disagree that it undermines his role as the architect. The math works regardless of his personal intuition. I mean, take black holes. The Schwarzschild solution, which describes the point of no return, the event horizon, it comes directly from general relativity. The fact that his framework was so strong it could predict these objects of infinite density before we could even conceive of them, that proves the strength of his design.
But he didn't believe in them. Carl Schwarzschild solved those equations from the trenches of World War I. Einstein published the work, sure, but he argued that nature would never allow such a catastrophe to actually exist. He did the same thing with gravitational waves. He went back and forth. He even wrote a whole paper arguing they didn't exist, only to retract it at the last minute. He drew the map, but refused to believe the treasure was real.
And yet, we're living in that destination today. You can't use a GPS without accounting for the time dilation his theories predicted. And what about the laser? In 1917, Einstein wrote the paper describing stimulated emission. That's the theoretical foundation for all laser technology.
But he never envisioned the laser itself. He wrote the paper and moved on. It took decades for other people to actually build the light amplification by stimulated emission of radiation. And here's the ultimate irony. We finally detected those gravitational waves, the ones he was so unsure about, using LIGO. And what is LIGO? A giant laser interferometer. It took the crumbs he left behind, laser theory and wave theory, put together by other scientists a century later to prove him right.
But that vindication proves my point. As the source material says, his mathematics allow us to commune with the cosmos. Whether he personally believed every single outcome is, well, it's secondary to the fact that he built the framework that still holds up. His blunders are more powerful than most scientists' greatest triumphs.
Oh, the framework is brilliant, absolutely. But his legacy proves that genius is a seedbed, not the harvest. He provided the seeds, and often by accident, but it took the collective work of the whole scientific community to grow them into something we truly understand.
Well, perhaps that tension between the individual architect and the collective verification is exactly what drives science forward. There's definitely more to explore in how these ideas keep evolving.
Absolutely. Einstein started the conversation, but he certainly didn't get the final word.
Thank you for joining us on The Debate.